Ooh, it's time for some more fun with rational functions. This time, we're going to write the equation of a rational function in factored form that is a horizontal asymptote of y equals negative 2/3, and we have holes at x equals 2 and x equals 9/4. We don't have any vertical asymptotes here. We don't have any mention of x and y intercepts, although there will be, but it's just not part of this description here. So that's what we have to work with, and that's all we need to have fit our function here. So first things first, since it is a function, I'm going to throw down f of x equals and a blank fraction. A nice blank fraction, a blank canvas to paint my mathematical picture on. Yes? Okay, let's go. So I'm going to skip over the horizontal asymptote since I'm going to need to look at my degrees of my numerator and denominator, compare those, and go through those rules. I'm going to start working with the holes first, and then I'm going to go back to that horizontal asymptote. All right, so for the x equals 2, I would need the factor that would give me x equals 2. So my factor would be x minus 2, and that needs to cancel, so it needs to be present in both the numerator and denominator. All right, x minus 2 equals 0. If I add 2, I get x equals 2. That checks out. Now I need to deal with this fraction. These are a little bit trickier. I'm going to need to divide by 4, right, to get that 4 in the denominator. That would mean that I'm going to have a 4x. And then I need to have a positive 9, which means this needs to be minus 9 right here, so that I get add 9 over and then divide by 4. Also, numerator and denominator. Okay. So if you're able to do it in your head like I just did there, great. If we need a little bit more help, let's go through that. Okay. So 4x minus 9 equaling 0, I would add 9, so I get 4x equals 9, and then I divide by 4 to get x equals 9/4, and we can see that that checks out to what we had there. If that's still a little bit confusing for you, take a look at this. I can backwards engineer to this step, meaning I would have x equals 9/4. I want to get it equal to 0 because then the left-hand side stuff tells me what my factor is. I'm going to multiply by 4 on both sides and get 4x equals 9. Then I'm going to subtract 9 to get 4x minus 9 equals 0. There is my factor as we see in our current equation. All right, enough of that. Hopefully one of those 3 methods works for you. On to the horizontal asymptote. I've taken care of both holes in this graph. Now I got to deal with my horizontal asymptote. Well, as it sits right now, if I were to multiply this out, I would end up getting 4x squared as my lead, okay, my leading term there, and then I'd have some stuff after it. I'm not really too concerned about the stuff after it. My denominator, I'm also going to have 4x squared and some stuff after it, okay? To get my horizontal asymptote, I'm only looking at that lead coefficient, okay, the highest degree terms in numerator and denominator, all right? That would be my highest degree term, and I can compare my coefficients. Well, 4 and 4, that's just going to cancel out to become 1 over 1. So really that's not doing anything, right? I need to somehow bring in the negative 2/3. Well, if I were to put some parentheses out in front here and then around the rest of the stuff that we didn't calculate there, since that's all just going to be 1 over 1, how about I just pop a negative 2 here and a 3 right here? Well, now I'd have negative 8x squared and some stuff over 12x squared and some stuff. And I know from my rules of horizontal asymptotes that I would then have y equals negative 8 over 12, which is negative 2/3. And that checks out. So it looks like to me, we just need a negative 2 and a 3 right here. And boom, we have our equation with a horizontal asymptote of negative 2/3. We have the holes at 2 and 9/4. That was awesome. Hope that helped. I would try to go a little bit slow for you guys on that one and have a full explanation, so hopefully it didn't get too overwhelming. But good luck on your tests and things like that, because rational functions are dope.